Going to take a couple looks here at some midpoint questions. I've got 2 on the screen right now and then 2 more that I'll get to in a second. So we've got M. 0, 2 is the midpoint of some line segment AB, and we've been given the coordinates of A. That's 2, -1, and we can see a little graph here. We don't really need the graph, but it's going to help with the understanding of it. They would like us to find the X and Y coordinates of B. That would be the other end of the line. We've got a couple ways we can do this, and thankfully with the graph, we can actually do this just by counting the squares on the graph and figuring out, sort of the numbers that are required to climb or fall from one to the next. I'm just going to zoom in on the graph a little bit. And so I've got to go from A to M would be the halfway point. And if I'm going up, let's do the X values. So if I'm going left, that's 1, 2. So I had to go 2 to the left to get the X value to match the M. So I went from an X value of 2, to an X value of 0. So I had to go 2 to the left. Okay, well, if that gets me halfway, I'm going to have to do another 2 counts to the left to get the X value of B. So it's my understanding that the X value of B might be -2. I'm just going to draw that over here. Now, in order to go up to M, I can count my vertical or my Y values. Right now, I'm at a Y value of -1, and I will go up 1, 2, 3. A climb of 3, up 3 to get to the midpoint means I'm going to have to go up another 3 to get to the Y value of B. And so it looks like my Y value of B would be a 5. Okay, let's take a look at it algebraically and see if we can make that match. If we know the midpoint equation is going to be adding the X values, dividing by 2, adding the Y values, and dividing by 2, it's just the average of the X's, the average of the Y's. And I have part of that. I have the A coordinates, but I also have the answer. I know that M should give me a final answer of 0 and 2. So I can start plugging some stuff in here. I know that I should have an X value of 2 for the first part, 2 plus something. Actually, I'm going to call that the X of B. And Y, which is a -1, plus something. And I'm going to call that a Y of B, also divided by 2. And that's supposed to give me an M value of 0, 2. Okay, great. Well, I can't just go ahead and start guessing, although these numbers are fairly simple. I'm going to do some math. I'm going to actually take a look at that little tiny equation here I have. The yellow, not so good. A little tiny equation I have right here. There we go. For the x's is supposed to give me 0. So I am under the impression that 2 plus an x of b divided by 2, that should give me answer of 0 in order to get this number over here. Meanwhile, this equation, now the green's not showing up too well either, but just bear with me here. The equation for the y values, the -1 plus yb over 2, is supposed to give me an answer of 2. Well, now I have two equations that I should be okay trying to solve. So on the left-hand side, I would multiply both sides by 2 in order to get rid of the 2 in the denominator. And 2 times 0 is 0, so that's super convenient. So 2 plus the x of point B is equal to 0. Now I will subtract 2 on both sides, and I'll get that the x of b should be -2. Well, that matches what I did when I counted it on the graph, an x of -2. I'll come over here and I'll do the same kind of math. So I'm going to have to multiply by 2 on both sides to make the denominators cancel out, and which means I need to multiply by 2 over here. So I'm going to end up with -1 plus the y of b is equal to 4. I will add 1 on both sides, get a yb is equal to 5. And so that's matching what I got over here when I did the counting. So if you don't have the graph and you can't do just the physical counting in order to figure it out, you can do some algebra. Now, there's another way, really, if you don't have the graph, you can say, okay, well, if I went from an A to an M, and I went from 2 to 0, that's down 2, so I'm going to have to go down another 2. And if I went from a Y of -1 to a Y of 2, that's numerically up 3, so I'd have to go up another 3. But the algebra here is really elegant, really quite nice. And so it turns out that the point B would be at -2, 5. Let's take a look at this next question. We got the endpoints of the diameter of a circle. So we can just try to draw a circle. And what is a diameter of a circle? Well, a diameter of a circle goes directly across the circle, hitting the center of the circle. And I've been told I've got 2 endpoints. We don't really need to label them, but we can. So I've got one of the endpoints is -2, -6, and the other endpoint is 8, -2, which actually what I've drawn is not necessarily accurate. I guess technically speaking, my line should be going up like this. So really quickly, I'll just modify that. All right, so my blue line here is the diameter that we're focused on. And it says the endpoints of the diameter of a circle are 8, -2, and -2, -6. What are they wanting us to do with this? They are wanting us to find the radius of the circle, leaving your answer to 2 decimal places. If I'm going to find the radius of the circle, I have to understand that the radius is a distance. Radius would be a length. And so I'm not actually finding the midpoint equation, I'm finding the distance. But could I use the midpoint to my advantage? So I really think that there's 2 ways to do this equation. Because this is a diameter, I could get the length of the diameter and just divide by 2 because the radius is just half the diameter. The other way that I could do it is I could find the midpoint, which would give me the center of the circle, and find the distance from one of the endpoints to the center. But that sounds like more work. So what I'll do is I'll get the diameter by using the distance equation, add and subtract as appropriately. So I guess we'll subtract our x values because it's a delta x squared, and then we'll add the delta y. So -6 take away -2 squared. So -10 squared, -10 squared is 100. And this is -4 squared, -4 squared is 16. So it's the square root of 116. Which is about 10.77, whatever the units are, who cares? Well, that's the diameter, all right? 10.77 is the diameter. So the radius would be half that. So I'll just divide by 2, and I get 5.385. So I'm going to round to 5.39. So if we don't round the diameter, it's 10.77 something else. But then we get the radius is 5.39 because it's half the diameter. So all I had to do was get the distance, the length of the diameter, and cut it in half because that's what a radius is. Moving on, I've got 2 more questions to do. We'll tackle them one at a time, obviously. Well, I've been given point M is the midpoint of these 2 things. Point N is the midpoint of these 2 things. Find the slope of the line that goes through M and N. Okay, so I have to discover what M and N are before I can do any sort of slope. So let's discover point M. Point M is the midpoint of A and B. Well, midpoint is add your x's, divide by 2, add your y's, divide by 2, and you might be saying, well, you're not adding, you're subtracting. Well, these are negative values, so adding a negative value is the same as subtracting. It's just simple arithmetic. So -16 divided by 2 is -8. 10 take away 9, 19 take away 9, that's 10. Divide that by 2, that's 5. So I've got my M. Now I need my N. N is the midpoint of these 2, and I'm going to add and divide by 2. So -14 plus 6 over 2, -17 plus 11 over 2. And we get, what's that? -8 divided by 2 is -4. And -6 divided by 2 is -3. So I have my M, I have my N, and I've been asked to find the slope between them. Never forget what slope is. Slope is rise over run, or delta y over delta x. And in this case, we're using the x's and the y's of M and N, not A, B, C, or D. So I'll do my delta y's, 5 take away -3, and -8 take away -4. And again, you'll say, well, you're adding. Why are you adding? Well, because I'm subtracting a negative. So 5 take away -3 is like adding. And so I get a slope of 8 over -4, which is otherwise known as a slope of -2. And so the slope of those 2 midpoints is -2. Last, potentially more difficult, but last, I've got this midpoint M that is really not a point. These coordinates are kind of weird. They're linear equations. Is the midpoint of S and T. Form an equation and solve it to find the value of P. Just for the value of P, and then we can do the value of Q after. I'm sure there'd be a follow-up question to find the value of Q. Well, this is a lot like the midpoint question I did up here. If we know the midpoint equation for basic midpoints, I should know that the x values, which is where the P resides in the midpoint here, is to add your two midpoint x values and divide by 2. Well, in this case, my x values are 8 and negative 10. So that's 8 plus negative 10 divided by 2. 8 plus negative 10 is negative 2. Divided by 2 is negative 1. Okay. That means that this value right here, 4p plus 3, 4p plus 3 should be equal to negative 1 because I've been told this is the midpoint. So now I can solve for p. So I'm going to subtract 3 on both sides, get negative 4, and divide both sides by 4. Negative 4 divided by 4 is negative 1. I end up with negative 1 again. Just a coincidence, I'm sure. Let's do it again to solve for the y values, even though the question doesn't say it. I just probably forgot to copy that part of the question. So I do know that for a midpoint, it should be add your y's and divide by 2. Okay, let's take a look at our y values. 12 plus negative 8 divided by 2. 12 take away 8 is 4. 4 divided by 2 is 2. So the q value, or the y value in this midpoint, is 4q minus 4. So I'll add 4 on both sides. Divide by 4. And it looks like q is the fraction. 6 over 4, which is 3 over 2, otherwise known as 1.5. And so I found the value for P and the value of Q because I know the equations for a general midpoint, even though they gave me little linear equations inside this midpoint. And so now I know my P and I know my Q. All right, I hope that helped.